The first subsystem was the simulation and control subsystem. Due to the size of the subsystem and the number of people in our group, the subsystem was broken into two parts, worked on by Drew Hinkle and Dominic Dunn. This part of the subsystem that I worked on was to control the robot through simulation and experimental implementation. We first worked with MATLAB and the Arduino code to simulate the robot and experimentally determine the difference between our simulations and the actual movement of the robot so that we could build a KI controller that would modulate the speed and control the actual movement of the robot. More specifically, I had the opportunity to work on the MATLAB simulation and help debug the PI controller after it had already been designed by Dominic Dunn. That will be discussed later in Dominic's slides. As you can see to the left, we have a plot of the movement as determined when the motors were given a 1.8 volt input, which is about 1/4 of the actual max input. We use this plot to then build a KI controller, which was able to control the speed of the movement, or the speed of the wheels, so that we could slow down as we approached our desired position.
All right, so I, Dominic Dunn, also worked on the simulation and control system. So basically what I did was I designed the PI control to control the wheels and also the controller to control the error between the wheels. I also implemented the code to convert the desired position in feet or degrees and turn that into encoder ticks.
Actually, I'm not. You guys going?
All right. My name's Connor Ventura, and I worked on the localization for this project. So the overall role of the subsystem was kind of to provide the main motor control code and logic that incorporates all the other subsystems. So at least not in Demo 1, but in the motor control main project, I work a lot with Ali on I2C communication. So that was something I had to learn skills in. My contribution to Demo 1 was I kind of wrote the C++ code to control the motor voltage and read the encoders. This was a little difficult because I had to adapt it from moving one motor to moving two motors, which I did have some problems with. So the obvious necessary skills are C++, which I'm all right at, but I had to kind of refresh on it. I also have had to learn some I2C communication as well as motor control principles. I worked a lot with Dominic and Drew on incorporating their PI controller stuff into the code and kind of fine-tuning that. Where's pause?
Oh, what the fuck? Did you start it?
Yeah, I hit record.
You got rid of the thing. Probably because you moved the mouse too much. You gotta go Windows.
Oh, yeah, Windows Shift Q.